Okay, this is the more complete data set from the North Sea area. It's the age depth data set that comes from this paper by Lehman and Keegan, which is published in the journal Nature in 1992. And over here we have depth, we have age, and we have the oxygen isotope ratio. We're only going to work with these two data sets for now. Again, this is a more complete data set, and it's much more complete than the one that you're going to be working with, but I want to use this one just to show you, give you a feeling for some additional things that you might do with data if you happen to have data of your own, or if you want to play around with this. The data set is linked on the class page. So the first thing that we start off with would be to put a plot together. By now I think that's we'd all be interested to see what the data set would look like. And so very quickly we get a plot of the data, and we want to do the usual things, and I'm just going to run through the formatting. I'll use my favorite format there. We're dealing with two variables. One is depth, and the depth is measured in centimeters. This is the depth below the seafloor. This is the age of the sediments, and it's in years. So we have, again, a unneeded legend. We could put the chart title in there, and so sediment age versus depth below seafloor. Now, something that we haven't done yet would be to format the data set, format the data series, and you'll notice that there are some additional options over here under the paint bucket. We've got a marker. We can select the marker options. We can go ahead and take the default circle. For the fill, maybe we'll select a solid fill, and let's try a yellow. Maybe for the border, we'll use a black color. So we've changed that. Now, do we want to have a line connecting all of our data points? Well, in this case, a line might help. So we'll go ahead and put a line in there. So we've got our basic data set now, and we can see again that it's a more complicated data set than the one that you're working with, the one that we've talked about. And if we were looking at this, we'd say, well, your first impressions might be, well, it's definitely nonlinear. I mean, we can see it starts off kind of, as time increases, the age increases linearly with depth beneath the sea floor, but it looks almost curvilinear in shape. But if you look at it carefully, there's a linear band in here. There's another linear band in here. Maybe from here to here, as we make this transition, as we roll over into a much longer or much thicker section of sediment. And you can see right away, if we come in here and try to add a trend line, that, well, this really isn't going to do very good at all. The exponential doesn't fit. Logarithmic, interesting. We should come back and look at that. Okay, I'm going to delete the trend line for now, and what I'm going to ask you to do is to, well, let's come back up here. Remember, I asked you to pull out some of those shape tools. I'm going I'm going to draw a line in here. And you can see that there's kind of a roughly linear spot there. And let me draw another line. And you can see that we have a linear segment in here. And we have a linear segment down there. So just as kind of for context, look at this data set as a series of regions or a series of time periods or ranges of depths during which the age or the depth increases linearly. And what I'd like for you to do would be to mark off these linear regions. So coming back over here to the data set, let's take the mouse cursor, and if we set it right on top of a point, we can see 19.75, 1490. That's our first data point, right? That's our first data point. Now, if we come up to the end, and I'm going to call the end, let's call the end maybe 170, 70, 60. So I'm going to come down there, 170 to 760, and color that block. And then from 760 out to, let's say, maybe 394, that'll be another linear segment of the data. And I'll give that another color. This is the fill color. Let's give that a light green. And so I think you can see what I'm doing. And let's, as one last, to extract one last, you may disagree with this, but maybe a little linearity in the turn here, going down from 559 to 11,190 years ago. So what was that? I lost it. So down to 559. Okay, so we've got these three zones. I'm just going to do three. We're going to, pause it and let you all do, finish it up. But what I'm going to do, and just to show you where I'm headed with this, is I'm going to take this data and I'm going to copy it over here. And I'll just take this. I'll just take two of these. I'll take these first two subsections. And I'm going to copy them over here and paste them. And we'll give them the same labels. These are age and depth, but they're from different periods of time, different ranges of depth here on beneath the seafloor. So what I'm going to do now, we haven't done before, is I'm going to add data to this plot. I'm going to add these time series separately. They're going to overlay the ones that are already there. To do that, you'd right click with your mouse on the chart, and then you go to select data, and then we go to add data. Okay, now we get this name. Well, let's just give it a name which corresponds with the age of the sediments, the range in the age of the sediments, 1490 to 7060. Okay, so that's the data set name. Then click in the X values, and then come over here and select that range. Okay, now, whoops, that was haphazard movement of the mouse, which carried things off. Now I need to put the Y's in. Okay, so now I've got my, and you can already see that the values have shown up there. Okay, so we have this time series Let me click OK here, because I'm going to give you some time to do this, if you wish. And I could have plotted this series on top as well, so there's nothing to keep us from doing that. And but the next thing that I'd like to do would be to put a trend line in there. We've done this several times by now, and we're kind of we've assumed linearity here for all the data. And so we've got a straight line. Let's rename the variables so that they're consistent with the data that we have. And this is going to be depth. We've got a real good fit there, not surprisingly. And we could come in here and increase the size a little bit to make it a little bit more legible. Okay, so we've got a best fit line. This is the slope. The slope in this case equals the delta A over delta D. So it's I can't think of anything else to call it but a time gradient. And in this case, the quantity is 37.09, and it has units of years per centimeter. Okay, now what I'd like to get would be the sedimentation rate. And the sedimentation rate is going to be the reciprocal of this. So, I could type it in, or I could cut it and paste it. So I pasted that number in there, and I'll just put an equal. So I'll come up here into the equation bar, and we'll type in equal 1 over 37.09, and this is centimeters per year. Okay, so we've got some information from the plot at this point. We know what the gradient is, or the slope of the line. It's 37.09. We know what the sedimentation rate is, which is the reciprocal of the slope. It's equal to reciprocal of slope, and it doesn't like that equal sign in there, so we'll just forget about that. And, equals reciprocal of slope, and we've been able to extract portions of the data which behave linearly, which we interpret as behaving linearly, into separate columns in the data set. And to plot those up, at least we did for the first one. And we could do that for the remaining linear subdivisions of this data set, and get information about the time gradient and also the sedimentation rate and how they vary through time or as a function of depth beneath the seafloor. That's all I want to do for now.